Hi friends, and welcome to my weekly live stream about the Uno platform. My name is Jérôme Laban. I'm the CTO of the open source project Uno platform, and I spend about an hour every week taking a look at Uno platform issues and features and news about the .NET ecosystem or about Uno platform specifically. And I take a look at one very specific issues every week. Last week was quite interesting about digging into I think it was data context if I remember correctly. But that was fun. So this time we're going to be taking a look at performance traces and updating one of our tooling to work on more recent tooling and improving documentation. So we're going to take a look at that. But before we do that, there's a some new article that was written by Martin Zygmunt, who is on the stream, and that's about contributing Uno platform, contributing to Uno platform is making a nice video about explaining how to get from start to finish, from setting it up to be able to contribute to Uno platform, which is something that you may want to do if you want to participate in Hacktoberfest, for which Uno platform is taking part this year. So welcome everyone who's on the stream. I see Andres is here, Jose. I don't know, are you joining us from Brazil? That maybe sounds Portuguese or Brazilian. Jose has a question already. Do you have any news about Uno platform and .NET 8 RC2? So no, I don't. We pretty much get the bits as the same time as you do. So we take what's out of Visual Studio and .NET and try it out with the newest pieces that we get from the project stream. That being said, setting up for the stream, I noticed that Visual Studio 2022 17.8 Preview 3 has been released just a few minutes before. And I already got updated. And if you take a look at the .NET that are installed, you're going to notice that there's already 80100 RC2, which means that we have a set of new updates. And I hope this time, and actually we could probably test that right away. If I go to, I think I do have that folder. Let's go to and go to temp, and then I'm going to do, so this is an empty folder, and we're going to do .NET workload update or install. Let's go for install. So let's go for iOS, Android, Catalyst. I think they're called that, and macOS. Let's go just for those. Maybe it's Mac Catalyst. Let's go for iOS and Android just to begin with. So in RC1, there were issues with some of the iOS packages that were not signed properly. I think it was for Maui, so we may want to try Maui as well. But let's take a look at the downloads to see how they go. But if they are, then we're going to be updating UnoCheck. And if you don't know about UnoCheck, it's the tool that we use to get you started with Uno, that install pretty much everything that you need for doing some Uno platform development, whether it's for Uno platform itself or using developing with Uno platform. So if you want to make a client app, and we have manifests here that are defining what needs to be there. And so in the manifests, we have the versions that need to be defined here. So we can see that the manifest that we have when you're installing Visual UnoCheck, it's using RC1. And when we're going to be updating that to RC2, then we're going to target the newest version. And what we're basically doing when we're installing everything for the first time, at least for the previews, we're just taking a look at the version that have been installed by the tooling here. So I think it's, let me see, I think it's Mac Catalyst. If I'm not using the right one, I'm going to take a look at the file. That's the right one. So we're going to be downloading Mac Catalyst. And in this context, we're going to get all the versions that need to be integrated into that file. So later today, I'm going to be making an update that takes all those versions and updates them to the latest, and to get the actual versions that are installed. And actually, let's do Maui as well at the end. So the reason we're installing Maui as part of UnoCheck is that we also support, since Uno 4.10, the ability to have embedded Maui controls inside of mobile applications, which makes it gives the ability to reuse all the ecosystems that is coming from Maui for iOS, Android, Mac Catalyst, and Windows as well, and install that and use that into your own application. So now that I've installed all the workloads, I can do workloads list, if I remember correctly. And the versions that we need to include in that file just above are going to be 34RC2, 16.4, Net 8 RC2. So we're going to be changing that version. And same for, I don't see which one should I be seeing. So no, they're all here. So we should be having all of those. So we can take all the versions and put them in that file, so that when you're going to be updating, using UnoCheck and updating to the latest version, you're going to be aligned with the right version. So I hope that helps, Jose, in terms of how we're going to be supporting Uno for RC2. Now, that being said, you don't need Uno to be supporting RC2 in a sense that if you have an application that runs already on RC1, it's going to be running on RC2. And I don't remember any breaking changes that were included since a few versions of .NET 8. So you should be good to go with even with the .NET 7 application that is currently running properly. So that's it for this particular part of .NET. So we're going to see, I have installed the preview 3, so we'll see if we're going to find any new features or bugs that have been integrated included in that version. So that's it. So now we're going to be taking a look at the performance tracing. So performance tracing is something that's actually quite important, because when you have large applications, in some cases it can be problematic to if your application is too large. Sometimes it could be a bit difficult to troubleshoot and get information about what's happening in the app, but not necessarily profiling the app by taking a look at profile traces. So if you've already profiled an application that starts up using standard tooling, which I could probably do here. So this is a .NET new application, an Uno platform application that I just created, and it when you start the application, it just shows up using standard tooling. Oh, I've installed it. Just 1 second. So this is something that happens when you update the workload. So it may not work. We'll see. It works. Okay. Well, I'll probably close Visual Studio after this. So I started the application. Now, if you want to troubleshoot the performance of the application, you may want to understand what's happening in between. And you may not know, when something is created, or you put a actually, let's do this. If you put the navigation view in between, so it says this is a quite large control, and so it looks like there you go. And that control is we're creating a lot of sub controls and sub views and similar. And when you start with the provider, so you go to the performance provider here, and then you do CPU usage, for instance, and you start running the app. Let me see if it works properly this time. You're gonna get CPU usage in that context, but it may not tell you what actually happened. So let's dive a little bit into what the diagnostic session is going to provide us. But we can see that we spent 10% in the creation complete method, but the problem is that we don't know which controls were those. We don't know. So even if we take a look at the call tree, we do know that it's coming from test page, but we don't know which control that was. Maybe there were many. Maybe in there were other controls that were created. We don't know exactly, so it may be a bit difficult. So the idea here is to trying to determine which control are created, which property are set, and things like that in a more discrete way. And that's why we have some tooling inside of provided as part of the Uno ecosystem to enable what we're calling performance traces. And we're going to walk through the documentation that we have already, which may be a bit outdated, and that's why we're going to be taking a look at those, try to figure out what needs to be updated and change that so that you can use that into your own applications. So actually, let's keep that so we can refer to that. We can refer to it a little bit later on. So we have in Uno a specific NuGet package that's called Uno Diagnostics Eventing. The Uno binaries take advantage of those in a non-intrusive way. So if you don't do anything, it's there, but it's not used. But if you enable it, then some parts are going to be lighting up and give you a way to determine, for instance, when that's an example. So it's pretty close to what Windows called event providers. An event provider basically allows you in an app to say, well, I've done this, I've done that, I've started this, I've ended this, and all those informations are going to end up being inside of an ETL trace that you can load up with a tool that is called the Windows Performance Analyzer. And that tool is actually quite amazing. I don't know if you've heard about this one, but it does quite a lot of things, and it's pretty heavy in information, but we're going to take a look at what we can get there. So to do this, what we're going to do is just profile the startup of the current application that we have, and we're going to be doing a few things. Actually, let's do that already. Let's go and download Purview. So we're going to be downloading Purview. There you go. So it's already in. It's already there. Let's unblock it to have it run properly. So if you don't know Purview, it's a diagnostic tool that comes from Microsoft, mainly used to debug Windows, but it can be used to Windows applications, but can be used to debug actually more than that, particularly now that .NET is able to generate files that can be used there. I think you can debug Linux traces there also, if I remember correctly. So there's quite a few things that can be done for using this tool. So we have downloaded Purview. We're going to install Windows Performance Analyzer. So this one is actually something that you can install from your own tooling. So if you have Visual Studio installed, you need to search for Windows Software Development Kit. And then you take the last version, for instance, so 22.621 during the recording of that video. You do modify, and then you're going to be shown with the configuration of the Windows SDK. And by default, actually it is checked now or maybe I installed it before, but the idea is that you have to check that Windows Performance Toolkit checkmark here. And once you have, it will install the Windows Performance Analyzer, which is a tool that Windows Performance Analyzer. It's a tool that pretty much does a lot of things, but when you open it, by default, it doesn't show much. So it's pretty blank. You're getting guided through some of those things, but it can go into pretty much a lot of details about Windows when you use it for Windows directly. And what we've done inside of Uno is to allow for the tooling to generate trace files that can be translated into Performance Analyzer files as well. So let's enable this in the for a Skia application. So this documentation was not made at the time, was made before the time we created the Skia application. So the ones that can allow to run on Windows. But we're going to take the one that we have here that's built for iOS and adjust it a little bit so that we can get it to run for the WPF application. So let's see what we have here. So we have the app head, and we're going to be creating something here that we can call directly from the constructor of the app. So let's call it just enable tracing, and we got the Uno tracing. And we're going to be adding the missing packages so that we can see we can see all of this. So I think we are mentioning which packages need to be added. So we need to be adding the UNO Diagnostics Eventing Providers package. Let's add it specifically to this head for now, but it could be something that you can add to this head. Note that this is not something that you want to keep for your release builds. So you may want to not have that when sent to the store. It's not particularly useful. And now that the package is installed, we should be having less errors in the file. We have a file event sync here that is not used. It requires an iScheduler. Let me see if we can avoid having to do this. Otherwise, we're going to be installing reactive. Okay, no, it requires a sync, so we're going to be adding a new sync. Yep, so it needs a scheduler. So let's add the system.reactive package. So we're going to be adjusting the documentation based on that, so that we provide the right information there. Did it fail for some reason? It looks like it doesn't want to install. Apply. No, it doesn't want to install. So I'm going to be, oh, there. No, it worked this time. Looks like I clicked maybe the wrong button. Okay, so what we need to have here is a scheduler. So we're going to be using schedulers, or if it still exists. I don't remember. I can use the immediate scheduler for now. So this is the immediate scheduler. It's all about writing files immediately. It may be a performance issue, but for this particular tracing, we're going to be using this instead. So this looks to be outdated. It may be too old. So we have UNO Event Diagnostics Tracing Factory. This looks like to be the same thing here. So probably don't need all of this. So let's remove that. Okay, so we enable tracing, and then we're going to be writing in my documents a UNO trace file that will generate a file that contains the data that's needed to be converted. So let's try that right away. I'm going to be installing this, otherwise it's going to be bugging me every time. And let's see first if we do have actual information that's being written, if it doesn't fail. So we have we can see that we have the navigation view that was created properly. So we're good on that part. Now let's go take a look at the documents folder and see if we have information that's been created. It doesn't look like it was. So let's go take a look at where the trace folder was created. It may not be at the right place. Oh, it's best if we call the function, otherwise it doesn't do anything. Okay. So let's try again. Actually, let's start with the debugger and see if everything is working properly. So we have our UNO trace folder. We're generating something here. It doesn't fail, which is good. And then we're good here. So if we close the app and go back to our document folder, we have a UNO trace, we have traces, and we have a trace of 4 megabytes and a trace manifest. So I'm not going to get into details about the trace manifest for now, but basically it's 2 files that contain information that can be provided to a tool that will transform that trace into something that the Windows Performance Analyzer can load. Okay, so if we go back to the conversion of the traces. So we have to transform the trace here into a Windows ETL file that can be loaded. So we have the trace file, which was in the file we know about. We have the purview from Microsoft that's been downloaded, and then we can run the converter, and then we can say where to take a look at the purview command. So the tool is not something that's part of a NuGet package, and probably should be a part of a NuGet package, so we don't have to build the conversion tool manually. So for now, that's what it is. So let's go with the flow and do what the documentation says. So we can open the diagnostics eventing application solution. Use the ETL translator project that's here, and we're going to be changing the debug properties. I'm sorry, the debug parameters so that it goes to the trace folder, and it has to be using this trace. I guess that should be enough. And let's see what happens when we start the project. Okay, so we need to start purview with a set of specific performance traces. And then we're going to be navigating to the downloads folder, which I do see here. Actually, let's move this to another folder that makes more sense. So we're going to be moving it to the Uno trace folder, so that it makes it easier. So we go to this folder, and then based on what the application is asking, we need to be taking that line. So there's a tip on how to put purview in the right context, but let's not do this for now. And we're going to be starting purview. And we can see that purview is collecting, which is fine. That's what we expect. And we press enter. And then what happens is that we're going to be replaying, the tooling is going to be replaying the events that were recorded in the UNO trace, so that purview is handling it properly. So we can do stop collection, which is what the button was asking for. We're going to be using an anti-path. I think that's what the documentation mentioned about. Let's see what the documentation said. Copy paste. It doesn't say exactly what to press. So you've got to be basing that part. So we're going to explain that part. And we're going to see that there's there should be a file that has been created, purview data. So that has to be this one. That will tell what we can do, that we can load with the WP tooling, so that we can take a look at the performance trace. So now that we are done, we have the ETL file that the performance view extracted, and then we can open that file using WPA. And then we also need to use a tool that's called a file that's called WPA profile, so that we can analyze the content. So I'm going to take that file. In the profile, we have should be having browse, but I don't see it. So let's see what, oh, there you go. So if I have to click apply, then browse, then we go to the sources of the ETL provider. We have the folder here. We're going to be selecting that content, select the profile file, and there we go. That should be enough. So now we should be having some data, but for some reason I'm not seeing too much yet. So maybe we're missing something with the analyzer. So I can see that there's purview for itself. We got metadata info. We got purview. We get a lot of events here that are not useful. We got event tracing info. Okay, so we're missing information here, which means that we're not, the tooling didn't generate content properly. So we can see some of the events that have been generated by Purview for itself, but it looks like it didn't record anything of use here. Maybe it may be this, but it's not showing anything useful, so it may be missing some information or something other. So we're going to dive into the tooling to see why it's missing information and try to figure out where we need to go from there. Okay, so it's supposed to be a little bit bigger though. That's where I'm a little bit surprised. It's saying it's skipping a few things here. Maybe it's because the events are not known. So I'm wondering if there's something additional that we should be tracking. So let's go take a look at the trace manifest. Maybe there's something that doesn't work properly there. So manifest is a file that's generated by the tool that will determine what needs to be measured. And for some reason, we can see that we're missing some information. So it's doing performance measure start, measure stop, but it's not measuring that much. It's doing some parts of measure CPU monitoring, but it's not doing much. So we have memory monitoring. So I would guess that this one should be the right one, but it looks like we're not getting into the analysis of the rest. So maybe there's something that didn't work properly in the trace factory or the event provider factory. So we're going to be diving into that particular class and see what happens. And now in general, we're supposed to be seeing a lot more information, but in there we're not seeing much. So we're not stepping into this particular class. That means that the class was not built with SourceLink. Probably just a bit too old for that. Okay, so we have an event provider factory here. Does it do the right thing? Probably not. We have an event provider factory here for Xamarin. It looks like it's pretty much doing the same thing. Okay, so if we look at other providers, we have a file sync with a manifest generation. So we have some tooling that's writing traces with the scheduler that writes what it's supposed to be writing, but maybe that's the issue. Maybe the scheduler here didn't work properly. We have some serializer that writes content to the file with a manifest generator. It goes to search for the manifest providers. So manifest providers are things that are supposed to be in all assemblies. They're supposed to be named trace providers. So maybe there's something here that is not returning. So we can see that there's available providers, but for some reason, we're not getting all the providers. So if we search in Uno for trace providers, actually, let's go figure this one out and to see if there are actually trace providers. So we're using reflection to get into those trace providers and find them out inside throughout the Uno platform. And maybe in that case, we're not having the right trace provider, or maybe they're not discovered properly, or maybe it's because the assemblies are not loaded properly, and that could be one of the issues here. Maybe the assemblies are not loaded properly and then they're not discovered properly. That could be something that happens in Skia. So we can see that there should be many trace providers. So we can see we can find some in application, in image, in in the layer itself. We get a lot in text block. We have many in the dependency object store. So to determine when we do get set in providers, we have many in the framework pooling. We have in animations, in storyboards. We have in resource resolvers to determine how long it takes to resolve a few things, and a native dispatcher here. So there's quite a few that we should be able to see. But what could happen is that because we're running this too early. Maybe there isn't enough. Maybe there isn't enough to run by. So it should be I guess it's that one. So we do have get assemblies, but maybe the assemblies are not loaded. So that may be one of the reasons why it doesn't happen properly. So maybe we can change the location of the startup here. So the tracing, maybe we can place it maybe here is too early. Maybe not. So let's see. So because we have a reference to that file, so let's put it in the main window. So we're going to be doing enable tracing directly inside that method. So the assumption here is that because we're referencing that type, the chain of dependencies will be automatically loaded. That's the assumption. So we'll see if we get more information about the tracing. Okay, let's start again. So for those who have joined, what we're trying to do here is to improve the tooling about the performance tracing that's inside of Uno so that it can work with Skia, Skia here, and have information that we can show inside of the Windows Performance Analyzer. So I've started the app again, and I'm going to be taking a look at the file that was generated, so the new file. The file is a little bit bigger, but you can see that the trace manifest is a lot bigger, and that's very encouraging. So let's see what we have there. We have application, we have framework element, we have visual state manager, dependency object store, all good. So that's what we needed. So now we can restart, so we can take the path to that file, and we're gonna be re-recording the trace, so with the performance analyzer. So let's change the file path here, debugger. And let's restart the process. We should be having more information. So there you go. So it asks to start the purview with more parameters. And then we're going to be starting purview again. So we're done. Purview is recording. We can press enter. And then we're replaying a few of the events that have been recorded. By the looks of it, it says that it will be waiting for 2 days. Looks like a bug in the recording, but that's fine. Now that we have replayed everything properly, we can stop the recording inside of Purview, and we're going to be taking a look at that new file. Okay, so we should be having a new file to load. Actually, it's actually the same one, but with a bit more information. So 23 kilobytes, not too much, but maybe enough. And let's see what we have there. So we should be applying the same profile that we used before. And there you go. Okay, so we have some more information. So we have the event metadata, not particularly useful, that is coming from Purview itself, so it's not super useful. So we're going to be removing that one. And we have the Uno dependency object store that shows us some more information about what's been happening. So we can see that here, there's only one. There were a few properties that were created. It sounds a little bit weak in a sense that there should be a lot more created, but we're going to try to figure out why that happened. So what we can see here is that we had a few of those properties that were written. So we can see that there was a brush that was written, that was get, there was a brush opacity. We had the creation of a solid color brush. So we created 3-color brush. It seems a bit too small, but anyways, that gives us an idea. Same thing for, so we can, if we zoom in here, actually, it's probably going to be easier. Let's zoom in there. We can see that there were a few operations that were created. So when we do have start and stop, there's automatically a section that's created automatically that will tell you when something happened, and that allows you to determine for how long that section took. So, for instance, if I think if I can select some section, it tells me how long it took. So you can see that between those two events, there were approximately 3 milliseconds that were there. So that tells us that operation was actually quite fast, but 3 milliseconds, depending on what needed to be done, could be too long. So it determines what we need to do, but it gives us the idea of what's been happening. So now, what's interesting is that we should have been seeing a lot more information than that, and I wouldn't be surprised if the file that was created was maybe closed too early, so not flushed in any way. So maybe that's something that we need to change again. Let's start again, and this time maybe we can maybe ask the provider to flush itself. Maybe I don't know. Let's see. There was a file sync here. It writes. So we had a write events. It schedules immediately and writes. So it writes immediately and does it stop task? What's that? Stop. Okay, so we can stop the file sync. So we're going to do that. We're going to stop the file sync when the application stops. It's going to be easier, and we are going to be able to see exactly what was recorded there, because it looks like there are some missing traces there. Particularly because we're starting it way before that happened, way before anything happens. So we should be having a lot more information in the trace. So let's see, do we have a close? We have a closed event here, and we're going to be storing the file sync here. And when we're done, when closing, we're going to be stopping the file sync. So I think it's an async method. So we're going to do something like this. So the problem here is that because it's an async call and there's nothing async that we can do here, I'm going to do something that should not be done. But we have wait. We're going to be waiting for the file sync to actually stop itself properly. That being said, it may not work. It's a task completion source. Stop task. It only stops when events. Let's see. So what does that do? So it's supposed to be called on stop. We have a binary writer, and only writes when stop task is not null. So okay, so we may be able to have something interesting there, but we'll see. So the writer, serializer is writing immediately. Is it flushing? It's supposed to be flushing, so we should be having something right away in the file, but maybe we were still missing something there. Okay, so let's restart the whole thing. Let's see if we get a new file that is actually interesting. Okay, so we're having an implementation error that was set at the top that says the type provider is not the right one at the top, but that's fine. We get a few others that are useful. And if we close the app properly, and it's not closed because it's probably waiting for something else. It's waiting for an event to happen. Okay, so it's not particularly useful there. Let's see, is the file bigger this time? Some not particularly, but maybe this time the file will probably will stop correctly and not push us to the end. and I'll have to wait for 2 days. Let's see if we get something interesting here. So let's run the tool and see without starting. Okay, so it looks like there's definitely a bug there because it's not supposed to be waiting for that long. The thread ID also is completely incorrect. So this may be, that is very interesting. Because that would mean that for some reason the file is generated completely incorrectly. That the internal structure of the file is not the right one. So maybe there's a version number that changed for some reason. Let's see. So there's a preview version of the package that we were using. Maybe that's one that we can take a look at. So that's system reactive. Okay, so there's a 2.1 dev one. So I don't know if there were many changes there, but let's try it anyways. And let's see if we restart. Oh, actually, I should be removing the stop there, but okay, so we have a start. We close the app, so it's not writing anything, but that's fine. So in the traces again. Okay, so we have a file that has some content. Let's try again with the event tracing tooling. See if we get something more interesting. Okay, so that's better. It actually recorded properly. So it looks like there's some kind of a race condition at the end, probably because the app is not supposed to be ending that way. So maybe we need to actually change the tooling so that it stops the recording properly. So let's do it right this time. So we have purview. We can start purview again. It's recording. We replay the events. We're done. We can stop purview. And let's take a look again at the file to see if there's something interesting, a bit more interesting. Okay, so we still have only one dependency object that is created, which does not make sense. It's actually 3. There should be a lot more than that. So maybe it's related to the way the file sync event was created. Maybe it's stopping for some reason. So it's scheduling something. Maybe it's blocking somewhere. So let's try it with another performance with another scheduler, maybe something like that. So you remember that at the beginning I said maybe the event sync here, the scheduler image is the right one. Maybe not. So let's use new thread instead. So new thread is not supposed to be used. New thread scheduler.default. Okay, new thread scheduler.default. So let's see if we get something different there. It's a little bit slower, which is good, because it may mean that there's more processing that's happening. Then we can close. Let's take a look at the trace again. Is the trace bigger? Not really. It's not bigger. So if it's not still not giving us some more useful information, we're going to be diving into the tool to understand if it's inside of Uno, if it's inside of the tooling that we're running that doesn't give us the right content. So we have the trace, and if we press enter, okay, so we have, this is quite interesting. it really feels like the file format is incorrect for some reason. There's a discrepancy between the reader and the writer that makes it not write the proper content. Let's try it one last time to see if we have the right content. Okay, so we have our diagnostic tool that's here. We can close per view. We have an ETL translator again. So we take the per view and then we start it again. It's recording. Press enter. There's not enough information. It should have been taking a lot more than that. Let's take a look at it anyways. Oh, 21 kilobytes is definitely not enough. Okay, it's probably just writing just one or two events and then stopping. Yeah, it's still writing the same few events and then stopping. Okay, so we're gonna try to troubleshoot this and see where everything goes. So the application we have here is depending directly on that package. That's diagnostics provider. And that provider is, which version of it? It's the Net5 version of the binary. So we're going to be building that version as well. So provider, and in the provider, we have a Net5. There, we do have a Net5. Okay, so if I build this particular provider, just taking a look at the manifest events. So we have the file sync that's supposed to be writing events in the right order. And so this one is determining the providers that are available. We have a file sync manifest. Okay, so let's build this and let's go take a look at what we get. So we have to get the Uno 5 the .NET 5 version of the file. So let's go in that folder, and we're going to be doing some overriding of the NuGet package cache. So to do that, we'll take the path of the NuGet package cache file, remove the path, and then we take what's from the output of our build and override everything that's not in the right folder. So we're not taking about eventing. We want to have the providers one. And the providers one is providers Net5 there. That's the one. So providers, we take all the files that are here, and then we paste that into the other folder and overriding what the application that we're building is going to be using, so that we can step into and see what happens. So if I put a breakpoint at that location, should be getting into the sources for our factory, if it works properly or it was rebuilt properly. Maybe I did not rebuild properly. Let's do that to be sure. Okay, there we go. So we're in the source. So we had the file event sync here that's created. It's generating its own manifest, which is fine. It's writing to the file that's the trace file. We have the magic and the writer, and then we should be writing all events that are coming through here. Oh, the XAML Llama is in the house. Hello, Michael. How's it going? We're doing some performance profiling, or trying to at least. So we're supposed to be writing some content. So we see that we're writing something from the provider here with a descriptor and some details. So we can see that we're coming from the external code. We did have a nice Thanksgiving. Thank you very much. That's having a little pause is always welcome. I'll ask you the same thing for your southern Thanksgiving. So we can see here that we're creating a dependency object store. So this is the creation of a new dependency object. And we're getting to the right event, which is what we expected. So we're scheduling something here. And it was supposed to be writing all those events in the file. So we can see that we're writing a lot more than just one. So the file is filled appropriately. You see it. The thing is that I wonder if there may be some. So it's scheduling. So it's actual scheduling on the single thread. So there should not be any concurrency issue because it's managed properly by reactive extensions. So we should be in good place here. We get everything running properly. We get the stop task that is null. So that we're in a good shape. So it should be working properly. But for some reason, when we're done with the generation of the profile, when we're reading it from the other side, it doesn't read properly. So maybe there's something that changed in between that was not aligned properly. So we're good there. We can probably stop remove the stop here. It's probably not that useful. And we're going to take a look at the other tool that reads the trace and try to see what happens, because it looks like it's running properly. So the trace is probably way too small. Let's delete everything, and we're gonna restart a proper full trace. So that we get the right file. Okay, so the file is still locked, but it's probably going to be telling us. We can see that it's 4 megabytes, which is fine. Then we can close everything. Then we're going to be rereading that trace and see what's happening in the eventing tooling. So if I change that file to be this new trace file, there should be something that we're doing here that reads all the traces, that generates the events, and we have the enumerate event method here that takes all the traces that were generated by the application and replace them so that the purview tool is able to read them again. So it's the trick that we're doing here so that we get the right information. But for some reason, when we're reading the data from the file, it's definitely not doing the right thing. So it's stopping too early, or maybe stopping at the wrong place or something like that. So let's see what we get. So we're reading the version, that's the right version. Then we're going to be reading events one by one. So that particular payload should be aligned with what we get on the other side, what is written by the other tool. So maybe that's what is different. Maybe there's some discrepancy between what is read on one side and written on the other. So we're going to be making sure that we're actually reading the right content there. So we have one event here. Got no keywords, and we got a payload. So it's made to be super fast and not too intrusive in your app. So that's why it's all, there's no string, it's only bytes and things like that, so that we get information. There's a table that's generated, I think at the beginning or the end, that gives us the proper information so that we can avoid having issues of performance issues. But that's pretty much the idea. I see there's There are a few IO exceptions that are handled in some way. Okay, so we're reading events. It looks like it's doing the right thing. It looks like it's doing replay real time. What is that doing? Oop, not the right file. So originally we didn't have any way to translate something that comes from a file that was generated on a different file on a different app and then generate the content using ETL traces that are on Windows. So what we took as an approach when coming from a mobile application is just generate a file that we can replay as events go by in the app, and so that they can be as close as what was originally recorded in the application. So that's why we're looping into the events and then have perf view just regenerate the file in the right format. Because at the time there was no way to do that. Maybe there's a new way that allows to generate ETL files without having to go through all that replay of files. But that's what we had originally. So by the looks of it, there's something different there that's not working. So we're getting the last timestamp, which that's why. Okay, so we're reading all the timestamps. We're getting threads ID. So, okay, so that's probably not the right thing. So we have 2 threads. We have last timestamp is 0. Okay, so that may explain why we're having issues there. Let's try to get it right again. Last timestamp is 0. Okay, so that definitely is a bug. We should not be having events that are having dates that are so different. Well, maybe all the events that are red are just placed at the first date, which may be. So if we take a look at the elapsed ticks, actually let's write some events there. Elapsed ticks here. I'm gonna log up way too much, but that's fine. So elapsed ticks should be giving us where we add in the file. Let's see when we run the thing. Okay, so we have some information that moves up, but there's a lot of it that's set at 0, which is in itself very, very odd. So that means that the last event is set at 0, which means that we're not reading the right information. Okay, so why would that happen? That may be because the information that we're writing is incorrect. Could be out of order. So let's see what we do in the file sync. We are writing a few things. So let's split the two and take a look at the information that we have on both sides. So we're writing the provider, we're writing the elapsed 6 as a long, the thread ID as an integer 32 bits, the event descriptor is an integer 32 bits. We have the opcode, that's a byte, the task, that's an integer, the version, that's a byte, channel is a byte as well, keywords as an int64 signed, level, which is a byte, activity ID, that's a long, related activity ID, that's a long as well. Very good. We have the data length, that is an integer signed. And then after that, we're going to be writing data types. 0 being a string. So we're reading a string here. Okay, so we're writing a string. 1 being an integer. So we're reading a byte of an integer, that's fine. and 2 being a long. Okay, that makes sense. And it doesn't look like we're writing anything else. So unless we're writing something completely wrong, which may be the case, but feels curious, let's go take a look at why our event file sync is doing such wrong serialization. So we're gonna go in the file sync event again. We're gonna take a look at all those events that are coming in and see if we can get something that's different in the generator. So either we're writing elapsticks that are completely wrong, which maybe, but we haven't watched that supposed to be writing the right content, so there should not be any problem there. So elapsticks is always, so we can see that elapsticks always has a value that makes sense. So it looks that we're having something that that is correct. Are we getting into the 0, for instance? Maybe for some reason we're jumping into the 0 size and that we're not reading it, which could desynchronize everything. That could very well happen. So if I remove this part, are we going into the null provider? Okay. That is really long. Okay, so it's probably broke for some reason. Let's try again. That is curious. So where are we? We're in the write scheduler, and it's not writing the file for some reason. Is it because the thread was not created? Doesn't look like it's working properly. So let's use a different scheduler. Maybe there's something odd there. Maybe we're not writing the files in the. So there's a new task scheduler. It's supposed to be default. No, it doesn't exist. Task scheduler. No, that's not the right one. Task pool scheduler. Get default. Okay, so let's try with that one. The problem with new thread is that it's not supposed to be recreating an event every time, but for some reason it looks like it's doing something wrong. So let's try again. Okay, so this time it worked. We didn't stop in the wrong event, so maybe there was something there with the right schedule, that scheduler that was writing something wrong. So let's see with the last traces. Oh, that trace is bigger. This is interesting. So there's some movement there. So maybe it's related to the scheduler that was used there to record the data. Okay, so let's try again. Let's try again with the debugger, and we use the new file. And okay, still not warning. You can see here that we're still having events that are incorrect. It's not supposed to be happening here. So let's see. And you can see that it stops very quickly, probably because it's written incorrectly. There should be a lot more data that's available. So we're going to be writing some more content to see what provider is actually breaking something. Could be of interest there. Okay, so the time is here. The provider is event data provider. Oh, okay. So we need to transform that into a GUID. Okay, so we're writing something interesting, and then we're breaking off at some event here that says 0 with a provider of 0, and then we're getting back on our feet for some reason. So maybe we need to still take a look at what's happening in the provider here. It doesn't look like it's right. Okay, so let's try again. Hi, McNets. Well, thanks for stopping by still, and we'll see you next time, next week maybe. Okay, so we are here, and then we're gonna try to take a look at the events that are sent here, and see if we have the right information. Maybe we're not getting the right information. So we have with a thread ID here, and then the event descriptor. Actually, let's go in the serialization. It's probably going to be easier to see what we get. We're going to get more information out of it. So in the event descriptor, we get a provider ID. So the provider is always the same one. So we saw that we have the provider 430FC. So that's the one that we're getting. So we're getting about 7 events or 8 events that are correct. And then after that, it breaks. Okay, so it's always the same. Oh, no, it changed. It changed, but no, the events are the event seems to be the right ones. They're not broken in any way. Okay, so this really feels like a it really feels like some race condition that's happening that's preventing the file to be written properly. So the assumption here is that the writer here that we have in the file sync is actually writing sequentially, but that may not be the case. So let's lock it for now and see if we can get something of interest. So maybe because it was running on a different platform, or maybe it was running on the mono runtime, maybe it was behaving differently. So let's lock on the writer for now. It's going to be our gate, but we're going to change that to be a single event, a single instance. Okay, so we have our data here. So we got the providers in the right place. So we're going to be doing the same thing that we did before, which is take those files that have been generated just right now, copy them over to the destination. And then we're going to be rebuilding the original app so that we can get the newer version that has the lock, so that we know that it's not overriding itself or doing some incorrect things. Okay, so let's try to record once more. So we have our file. Let's see if we have something interesting as to the size. We have a 4 megabyte file, which is pretty close to the original. We take again the path, and we go to the debug launch here. And let's run the file. Ah, that's so much better. Okay, so definitely it was a threading issue. I was under the assumption that everything should have been running in a single line, but it's not. And I'm starting to think that actually the one that we should have been using is not a new thread scheduler, but it should have been the event loop scheduler. That's the one that we should have been using. And that one is ensuring that everything runs in a single thread. So it's a single thread that's created per event loop scheduler, and then all the events that get processed one by one without having to put a lock inside of the events that are processed as part of the subscription to that scheduler. So that's probably why we missed that part. Okay, so now we're at the right place. So we have a lot of events that have been generated. And we're going to be removing that event trace here because it's going to be slowing down the recording. So let's go back to the event provider program here. So let's remove the right line that we had at that location. And then now we have the right file. So the file is generated properly. Oh, it's still running. Okay, so I probably was too fast. Control C too much. Okay, so we have the right content there, and then we're gonna be restarting again the perp view. It's recording. We've replayed events for about 2 seconds, which is not too much, but that's probably fine. We don't need more than that because the application didn't run that long. We stop the collection and we should be getting a file that's a lot bigger now. There you go, 10 megabytes. That's a lot better. So now we're going to be getting some more information about what's been actually happening in the app, and you can see that that the file is looking a lot nicer now. There we go. That's a lot better. So let's zoom in into this part. So we get a lot of dependency objects. We can see all the instances here. So all those blue lines that are the vertical are actually new dependency objects that have been created as part of the startup of the app. We have resource resolving that happens 24 milliseconds. We have a storyboard that starts, that runs for about a second or two, I don't know. No, 160 milliseconds. So not too long, but still, something that's running for that long. We have template pooling. So that one is interesting. So we have a few events there in the template pooling where we can see what's been recreated, which template have been created and which have been recycled. And we can see that during the startup of the app, there's only, is it one? Okay. There's one instance of a control that has been recycled. I don't know which one that is. It doesn't tell specifically, but at least you can know which have been created. But you can also see which templates have been created. So if you take a look at those values, well, it doesn't say much, but you can see that it's internal templates there. Probably improve that one, but that gives you an idea. What can we see? We can see also things happening in the so the Visual State Manager that says go to state. So that's a lot of go to state, 89. So for all the controls that we've created, maybe it's too much, maybe not. We don't know. No, it's things that can show information of some interest. Maybe if you're running something in your app and then nothing's supposed to happen, but you'll still see things happening. That may be something that can be of interest. You have the start and stop of the app. So the app actually ran for 1.7 seconds. There was still a bit of information that was happening afterwards. Oh, actually, I'm sorry, it's not the app starting. It's the unlaunched method. So that the unlaunched method ran for what does it say here? Probably gonna have to select that. It ran for about 400 milliseconds. So that's one of the interesting things. And then we have other things like the framework, framework element. So it tells you, measuring start and stop. It tells you how many measured with it. So there were 127 framework elements that were measured. Probably a similar value with range. So you can see that there's a bit of difference there. There are 3 elements that were measured but not arranged. That's something that's very interesting. I would have expected to see the dispatcher, but it's not there for some reason. So probably not recorded for some reason, or maybe not executed. And then we can see that there's a lot of value, the dependency property, get value and set value. And there's a good reason for this. There's a lot of things that we can do to determine if something should be read, not read. If you're reading some values for some object that should not be there, or maybe we're changing changing data context too much. That's something that's of interest. We can see that there were 1,250 changes, data context change event args, events that were raised on all the objects. So that's quite a few of them. So that's how we drive the optimization that we can make inside of the Uno platform, particularly with those get and set values. If those take too long, that's a problem. So that's the kind of optimization, the optimizations that we can make. to make the Uno platform go faster. So that's the kind of tooling that you can get when you're analyzing all this. You can make your own and record them as the rest, and you can say, well, I've started navigating here, and then all of this happened during the rest of my app. So that's the kind of thing that are of interest. I see Oxter is asking, I assume I can run my app on Linux and then eventing enabled and then take the traces over to Windows to analyze. Yes, definitely. The point of the whole thing is to be able to run it on WebAssembly, on Linux, on iOS, Android, any platform, and then take that file, transform it so that you can run and see the context that's available for you to take a look and analyze. So that's pretty cool. That's a CSI type of work. If you're interested in the kind of looking down for information, it gives a lot of things to chew on, but it's super interesting. And if you end up using that tool, let us know. So I'll be changing the documentation so that it gets a little bit easier to use and up to date. But let us know. Let us know if you get actual insights out of this. We do when we dig a little bit more. And yeah, that's it. So I hope that session was interesting. It was for me because it's been a while since I've been doing this. And until next week, happy coding. Bye for now.